All right, we're going to get started with a quick video just summarizing what we learned today. So today's lesson was mostly a review, but let's go ahead and put this into our notebook. So get a notebook out, whether that's a notebook that you took from school or just like a piece of paper. I forgot my notebook at school, so I'm just working on a piece of paper, but I'm going to make sure to save this and everything else that I need so that I have a record of all the learning that we've done over the next couple of weeks. So today we're going to title our notes it's a review of right triangle trig. Even if you feel like this is a topic that you know well, I would love for you to just go through the process of writing this down so that you get really comfortable with taking notes off of a video. This is our first distance lesson, so I want to make sure that you all have everything that you could possibly need to be successful. So essentially the biggest thing that we need for our right triangle trig, well, first we need a right triangle. Let's do that right now. Okay, maybe yours will be cuter than mine. Let's call this guy 40 degrees. Okay, fun fact, all triangles add, all angles in a triangle add to 180 degrees. Can we see that? Great. Okay. All angles in a triangle add to 180 degrees. So this is the angle that we're given right now. We're going to basically pretend that we are this angle when we label. We're going to have like an opposite side, an adjacent side, and a hypotenuse. So label the opposite, adjacent, and the hypotenuse according to the given angle. So that means that like if you're using this angle, your labeling would change. The only side that doesn't change is the hypotenuse. But the other side is going to be either the opposite, so across, like literally like across from the angle. I'll do that again. Like literally across from this angle is the opposite side. So opposite. The hypotenuse is always across from the 90-degree angle. So across from the 90-degree is the hypotenuse. It's also the longest one. And then the adjacent side is this angle here that is like touching the angle but not the hypotenuse. So that's the adjacent. Why is that so important to know? Well, when we talk about SOHCAHTOA, which is like referencing basically the trig functions that are sine, I'll write them up here, sine, cosine, and tangent. These are functions that take in the angle, like you give them the angle, and what they spit out is the ratio of the sides. They spit out the ratio of the sides. So that's going to be, also like you're going to see me only write the first 3 letters, sine, cosine, and tangent. Don't be one of those people that calls this sin because they're used to saying it like that. It is sine, that's the proper name. I mean, you could be one of those people if you want to, but you know, we try to learn it. So sine is referencing the opposite over the hypotenuse. So the sine of 40 degrees is going to be the opposite side over the hypotenuse. Cosine is the adjacent over the hypotenuse. Color code. And tangent is the opposite over adjacent. Great. Fun fact, tangent is just sine divided by cosine because the hypotenuse would drop out of the denominator. So what we're going to use is we're going to use this information to like solve for one of the missing sides. So solve for a missing side. You might be wondering, like, where does this fit in big picture into what we're learning in this entire unit? So essentially, like, the big picture idea here is that we're going to be talking in this unit about something called the unit circle. So just as a quick sidebar, we'll be talking about unit circles, which is like a circle that is centered with a radius of 1 at the origin. But what we'll be doing is creating essentially right triangles. Like, our goal will be to like find the coordinate here, and in order to do that, what we're going to do is create a triangle. I'm just going to zoom in on that part of the circle. So like to find that coordinate, we're going to set up a right triangle. We'll know the hypotenuse, and we're going to be given the angle and use the angle to calculate the side lengths here and here. So that is why we need our right triangle trigonometry when we're doing this lesson. So this is really the foundation for the unit circle work that we're going to be doing for the next couple of weeks. So we need to know how to solve for missing side length. So I'm going to set up a triangle. We'll use our 40-degree angle again, and we're going to call this length, let's call it 2. Okay, we know that this is the longest side because it's the hypotenuse, it's across from the 90-degree angle. So just thinking ahead that like this height should be less than 2 once we get it. So if you get something bigger than 2, you know something went wrong. And we're going to solve for x right now. So real quick, just to figure out which one we're going to use, sine, cosine, or tangent, we're going to reference the fact that this is the opposite side from this specific angle, and this is the hypotenuse. So because we know the opposite and the hypotenuse, O and H, that tells me that I'm going to use sine. Okay, so I'm going to set that up. Sine of 40 degrees equals x over 2. Boom, this is where I need my calculator. I really like to use my Desmos app. So you'll see I have my Desmos app. And what I'm going to do is first make sure that I'm in degrees. If you don't have a like fancy calculator at home, I really recommend downloading the Desmos app because it's just really helpful. Make sure that you're not in radians, you are in degrees, and then right in here you're just going to type in sine, sine, S-I-N. You can also go to functions to get that. And we'll put in 40 degrees, and it is 0.6427. So we're going to round that to the second decimal place, call it 0.64. Notice that it has, so 0.64. There was a 2 after this, and because that 2 is less than 5, I'm not going to round up at all. Equals x over 2. To solve, I'm multiplying both sides times 2. Times 2. I can just go back to my calculator, leaving that on the screen, and then just press times 2. Oh, do you see what that just did? Weird. Okay, delete, get out of there. Times 2 on the outside so that it doesn't put that in the parentheses. Otherwise, I'd be calculating sine of 80, which is not what I want. So it gave me 1.28. This time, if you look closely, I don't know if y'all can see that. I'll raise this up. If you look closely, it says 1.285. So that 5 is going to drive the 8 up to a 9. So I'm going to call this 1.29. So this is going to be 1.29 equals x, which makes sense because if this distance is 2, then that makes sense that this is like 1.29, 1.3-ish. Okay? Fabulous. So there's our example for today. A lot of folks get stuck on wondering like what happens if the variable's in the bottom. So just as a quick instance of that, if we had had our 40-degree angle, let's call it 1.5 on this side, and we were trying to figure out the variable here, again, we'd be using sine because it's still the opposite in the hypotenuse, but this time it would be sine of 40 equals 1.5 over x, so that again is 0.64, but this time what I need to do is actually multiply the x to the other side. So I'm going to multiply him to the other side. So it's going to show up as 0.64x equals 1.5. And then I end up dividing 1.5 by 0.64. So I'll type that in here. and that would give me 2.3. Okay, so just as a variation, if the variable is on the hypotenuse and it therefore is in the bottom of the fraction, you end up dividing the top side length by the value of sine of 40. Okay. All right, y'all. So in summary, today our main focus was on reviewing SOHCAHTOA and on using SOHCAHTOA or sine, cosine, and tangent to solve for missing side lengths in a right triangle. Hopefully that is familiar from last year. If not, watch this again, jump on office hours, ask me questions. You will have plenty of opportunities to practice before we see each other next time to work on the unit circle. I hope that you all enjoyed this lesson. Please feel free to give me feedback or play it at 1.5 speed if you feel like it. You can go at that pace. All right, have a great day.